Today we're talking about writing and graphing inequalities. So if I go to a little list of numbers like this and ask you to demonstrate what are the numbers or the temperatures that are less than -4 degrees Fahrenheit, I've highlighted those numbers that fall into that category. So you notice there's more than one. This is a question that has more than one answer, and so that's kind of an interesting thing to note. The next one, circle each number that makes the statement true. So let me get my highlighter. Now you can circle on your paper as you do this, but I'm going to use my highlighter pen. So what is the statement? More than 3 students from our school are in the chess tournament. Well, more than 3. So what numbers indicate more than 3? Well, that would be 4, 5, and 6. Any one of those numbers would be bigger than 3. Notice how we didn't include 3 in that list because it said more than 3. Okay, so keep moving along here. This type of information and the subject we're kind of introducing here gives us a reason to introduce the subject of inequalities. An inequality is a mathematical sentence that compares expressions using less than, greater than, less than or equal to, or greater than or equal to. In this lesson, we're going to practice writing inequalities and graphing inequalities. So just some words that we want to get familiar with are these. If you see this symbol with an arrow pointing to the left, that usually means the number on the left is less than the number on the right, or is fewer than. When the inequality symbol is pointing to the right, this means that the number on the left side, like over here, is greater than whatever happens to be on the right side, or is more than it. And then by the same token, this next symbol means less than or equal to. So all the numbers on the left side would be less than or equal to whatever shows up on the right side. And in the last column, all the numbers on the left side would be greater than or equal to whatever shows up on the right side. A couple of other ways you can word that too. So watch out for some of those additional ways to word these things. So let's write a couple of inequalities, jumping right in and going pretty quick here. So a number W minus 3.5 is less than or equal to -2. So that would look something like that. Okay, second one, a number B is fewer than 30.4. Fewer than means just less than. So 30.4. That could be a temperature, or who knows what other subject, or an amount of money or something like that. Okay, the next one, twice a number k is at least 7/10. So twice a number k means double the number, and then it's at least, which means greater than or equal to -7/10. And I put less than or equal to because at least means greater than, but it could also be equal to. So there's some examples of inequalities that we were able to write just based on these phrases. Okay, a couple more. A number B is fewer than 30.4. So a number B is fewer than, so that would be less than 30.4. What about that next one? What would you do for that one? So -7/10, and it's interesting, they're writing this maybe a little differently than some of the others. -7/10 is at least twice a number k minus 4. So we got to get this other one, at least twice a number k minus 4. And then when it says it is at least twice a number, that means it is greater than or equal to this number, right? So it is at least twice this. So that's kind of interesting wording. Hopefully most of them are not worded quite so difficultly, but you just need to be aware, however it's worded, we want you to be able to figure it out. Okay, a solution of an inequality is this. A solution of an inequality is any value that makes the inequality true. And as we've seen, there are more than one answer. An inequality can have more than one solution, such as the ones that you see here. For example, is 6 a solution? So if we put the number 6 in for x, 6 plus 5, that would be 11, right? And is 11 greater than or equal to negative 2? Well, yes, it is. But is that the only number that works? No, there are others. In fact, a large number of them that work. So let's look at some more. Tell whether the given value is a solution to the inequality. So let's put the number 10 in for t. So we'll have 10 minus 3, and we're asking, is this greater than or equal to 2? Well, 10 minus 3 is 7, so of course it's bigger than 2, right? So it's greater than 2. All right, let's try this one over here. 6w is less than negative 2, so if w is 1, 6 times 1 would be 6, and we're asking, is 6 less than negative 2? And the answer to that question is no, so that would not be 1 would not be a solution to this inequality. Then our last one, 1/2 of d is greater than negative 3. Well, what if d is 0? So 1/2 times 0 is 0, right? Is 0 larger than negative 3? Well, yes, in this case, it happens that it is. So 0 is actually a solution to this inequality. So yes, it is. Okay, on Alex, it might look like this. On each value of w, determine whether it is a solution to w is bigger than 11, bigger than or equal to, greater than or equal to 11. Well, is 12 greater than or equal to 11? Well, of course it is. How about 14? Yes. How about 11? Is it greater than or equal to 11? Yeah, it's equal to 11, so that just barely squeaks into our yes section. But 7 is not greater than 11. It's less than 11. So it falls into the no category. So you have to go through each number and just verify where it belongs in this solution, okay? All right, so now when it comes to graphing inequalities, there's a specific method that we use. For example, if we have something that's greater than, we usually like, let's say, greater than the number 4 or something like that. We would put an open circle at that number with an arrow going to the right. That would indicate greater than. If we wanted to say greater than or equal to 4 or any other number, I'm just using 4 as an example, then we would color in the circle at 4 and then do our arrow pointing to the right. So a little distinction between greater than or equal to. One of them you don't color in the circle, the other one you do. Well, the same thing goes for less than. So if we're talking about less than, then we would have an open circle at whatever number we're comparing it with an arrow pointing to the left. Or less than or equal to, in that case we would actually color in the dot at whatever number we're comparing it to and have our arrow going to the left in that case. So it's all a matter of whether or not we color in the dot or don't color in the dot and what direction we point the arrow. So let's graph a couple. N is greater than or equal to negative 4. So it looks to me like that's one where we color in the arrow. And because it's all the numbers greater than or equal to -4, our arrow points to the right because that's where the numbers that are greater than -4 belong. The next one, b is less than -1. So we're going to put just an open circle in -1 because it doesn't have the equal sign under it. And all the numbers that are less than -1 are to the left of -1. So that's how we would graph that one. Okay, a couple more. A is greater than 6. So in that case, we would put an open circle at 6 and an arrow pointing off to the right. Now let's look at this next one kind of a little more carefully. We've got it kind of flipped over or reversed in the way it's written. So I'm going to rewrite it. Put T on the left, which is where we like to have it. You notice how the arrow is pointing at T? So it's actually going to look like this when we turn it around. So T is less than -1. Okay, so we just go to -1, make a dot, but don't color it in. And so all the numbers less than -1 would be to its left, like that. So once in a while, the inequality has been reflected, if you will, across the inequality sign, and so you have to watch how to write it and the other details. Okay, a few more problems, and then we'll be ready to start. So we're going to write an inequality that matches the arrow here. So in this case, we have the -1, so it doesn't tell us what letter to use, so we'll just say x. X is greater than or equal to -1. The next one, x is less than or equal to 2. And the third one down here, x is greater than 4. So that's how you'd write the inequalities that go with these particular graphs right here. So our assignment is number 31, writing and graphing inequalities on Alex. Good luck.